R is a great language to start programming. It is full of functions and full of features that will get you very far. You're not going to be limited in R, but it's also easy to learn for beginners. It is a language that is built by people for people that are not coders, that it is not their job to professionally code and develop softwares. We know when we build R that it is not going to be used by experts. R is often used by researchers because it is easy to use. It's just a few simple functions that they have to put one after the other. They can do very powerful things with it. The most advanced statistics being written into simple functions in R by the researchers themselves that just discover and build and design those statistics. You will have very advanced libraries to make graphs that in the end, they're just one simple function called. R has also a lot of written tutorials that are very good for beginners and that are very good for non-coders. The community around R is really about, learning from data, doing things with data. It is not expected that the person that will use R is an expert. That said, R is fully featured. You can do the most advanced statistics with it. The biggest organizations are doing their data science with it. When I work with R, I like to use it for its functions. Usually in R, you're not wondering if the function has been written, you're just wondering where it is because it has been written. There is a function to do everything in R. And this makes prototyping and just developing or researching through your data or trying to understand your data or just doing anything that you're not sure where you're going. R is really a quick way to do it, and it helps you really manipulate things quickly and look at things quickly. So once you installed R and RStudio, you can first open R. Click on your shortcut if you're on Windows, or open it like you would open any software. In my case, I open it in the terminal to show you the purest way, the purest R. R in this case is just an interpreter. An interpreter interprets the language, and so it takes in what you give it in a certain way, and then it knows what to do with it. So you can see here the R version is 3.6, and R has always a little funny name associated with each version. In this case, it's action of the toes. If you know nothing about programming, if you've never done any coding, you can think of the R interpreter as a big calculator. So let's try it. You'll see that if I do 1 plus 2 equal 3, 5 times 10 equal 50, and to get the results, I press enter once I've written what I want. And so here it just acts as a calculator. The reason why it's useful is that it's much more than that. And the much more is basically just functions. A function is just a name, like ABS in this case for absolute value, followed by parentheses. And then let's say -1, enter, and I get the absolute value of -1. So this is a function. It's some of the simplest functions you could have. A function takes an input and gives you an output, and in between it applies a recipe. It always applies the same recipe. You can change the input and it will apply the recipe to this different input and give you the different corresponding output. So in this case, absolute value, the function ABS takes a number, a number with a negative or just a positive number, and transform that into a positive number. And so we see that ABS -5 equal 5, or ABS 6 equals 6, because it's the absolute value of 6 is 6. So R, it's a language. It's a set of grammar, syntax, and spelling rules. And those rules, they can be written into a computer program, or they could be just told to another human, and then the human could decode what you're trying to tell it using the rule of the R language. In the case of R, those rules have been written into what we call an interpreter that will take your syntax, your grammar, and your spelling, and it will interpret it. And that's why it's called an interpreter. Let's say that we want to plot something. R comes with function to make graphics. And so we can just call the function plot and give it one for the x-axis and give it one for the y-axis. If I do enter, you see that the plot will appear. In this case, it appeared on my other screen, and so I just dragged it here. I could also make a histogram, so I can have the function called hist, and then enter, and I get an histogram. In this case, it's just one big bend. So now you're probably wondering, how do I know these things and how do I learn these things? What if I don't know all the name of all functions? There is two ways that you can ask for help in R, and the help is integrated into the console, or what we also call the interpreter. By using the question mark, you can get help. Let's say that I want to know, how do I have to use ABS, the function for absolute value? I would type question mark ABS, and then I do enter. And so you can see on the top, it tells me that it comes from the package base. Later in the video, I will explain what a package is. Then it describes it. It says that ABS will take a X and it will compute the absolute value of X. And then it shows you some example of how to use it. It will later tell you which arguments it takes. An argument I will also explain later in the video what it is. It gives you some details, and it even often in R gives you some reference to the scientific literature that are either developing the strategy to write those functions to be computationally efficient, or that are actually developing those statistics. If you want to leave this help, you just press Q. The other way to call this help is by writing the function help on the variable, or on the word ABS. Enter, and you see here it shows me the same thing. The other nice thing to learn how to use a function is to use the function example. If I type example around ABS, it actually generates and types some code for me. And in this case, it returned some plot, and it waits for me to hit enter to finish. So I hit enter, and you see now that it generated a plot. I could have generated this plot myself if I typed the line that were typed above. The last feature of the base R, the base console that I will show you, is the up arrow. If you use the arrow, if you press on the arrow that goes up, you can go back to all the previous lines of codes that you typed. So if you're like, you typed a line of code maybe 10 lines above, you're like, oh, it was long to type, I don't want to retype it, or I don't remember and I don't want to scroll, then you can use your arrows to navigate through the history of the code that you gave to the console. This is nice. This gives us some power. We can give numbers to function, we can use the help, and we can type it. But what if we want to write a whole script, like a series of steps, and that we want to run all those steps? We're not always going to go and type them in. So one thing we can use is a source, a script. So we can use a source file, and a source file is just a normal text file in which we write some R code. But what happens if I have a feeling it's called one way or another, but I am not sure? It would belong to always use the help and the question mark. And that's where a text editor, like a development environment like RStudio, that's when it comes to be useful. RStudio would autocomplete what you type, so that means that you can start to type the name of a function and it will complete it. Of course, when you don't know it at all, you will often need to go online and search for it, but there's a lot of help online, and I'll link some resources down below. So that's why we will now switch to RStudio. When you open RStudio, this is what you have in front of you. In your case, it might be black and white. This is just because I put a theme on mine, but otherwise everything should be quite similar. You see here in RStudio on the left panel, you see that you have the same thing as what we had before, what we were calling the interpreter. And you actually see here in the tab name on the top left, it's called the console. So this would act and be the exact same thing as what we had before. Everything that is typed here will do exactly the same thing as everything we typed in the previous console, the previous interpreter that we had. The first thing we do when we are in RStudio is that we open a script, or it's also often called a source file. To open a script, you'll click on the top left here and choose an R script. When you click on the script, it appears here on the top left. You see now it's untitled, and so we will just save it somewhere. So I'll do Control S, or you can do File, Save, Save As. So the script, or the source file in the left, for the computer, it's just a normal text file. You could open Notepad and write the exact same code in Notepad and save it with a .r and come here in RStudio and open it, and it would be the exact same thing. It would be read the exact same way and it would work. On the top left here, we have the script. In this script, we can type anything that we typed in the console before, but in this case, it can be saved as a normal text file. And when we do enter, it will just skip to the next line. It won't run it. It won't be sent to the console to be evaluated. For our code to be evaluated, we need to do Control Enter, and then you see that in the console here below, you see that 1 plus 2 and it printed 3. But this doesn't save our results, it doesn't save our work, and we can't use the result of this computation farther down in our code. To save the computation or to save values, we have to assign it to a variable. To save the result of 1 plus 2 in a variable, we can use the equal sign. And so here I can type a equal 1 plus 2 and I can do enter, and you see it was sent down below in the console. And on the right, now you see that the a is there in the panel called the environment. We see that a is a numeric value equal to 3. There are two ways to assign values or things to a variable in R. You can use the equal sign, or you can use the assignment operator, which is the arrow. And so if I do a arrow 1 plus 2, a is still equal to 3. If I do a arrow 110, you see now here on the right that it's 110. R is not sensitive to space, so you can just remove all space, put lots of space, but there is a style to which R programmers are used, and often it's very close to, there is a Google style sheet online that will show this style. We will put a link in the description below. Maybe the other thing about R is that R it's case sensitive, so capital A arrow sign 110 or 10 is not the same thing as lowercase a. If you look here on the right, we have the variable name capital A, and we also have the variable name a. A is equal to 110 now, and capital A is equal to 10. R will always overwrite its variable, no matter what it is equal to. Okay, so this is how we assign. We can use the equal sign, we can use the arrow. Space don't matter in R, and R is case sensitive. Now I'll show you the 3 basic data types plus 1 special one. R has 3 data types: the numeric values, character values, and logical values. Numeric values are numbers, character values are anything that is text, and logical values are true or false. So the first data type that I'll show you are the numeric value. And so I will save this data type into a variable that I choose to call my numeric, and let's say it's equal to 0.2. Enter. You see on the right it says it's numeric length 1, 0.2. Numeric values can be can have decimal points, or they can be what is also called an integer, and so that's without the decimal point. I will then show you logical value. So in R, to type a logical value, you will use either capital T, capital F for true or false, or capital true the whole word, like that. So you see here it says it's a type logical and it's true. So here my logical 1 can be equal to false with capital F. You see here that my logical 1 is equal to capital F, false. Okay, the third one, the last, my character. This is something that we can call with double quote, and this is the text. So my little story. The single quotes also work to tell R that we are about to give it a character. My little story. And I'll put a 1 instead here. Okay. So you see those are equivalent. And R transforms it. You see here RStudio uses the double quotes, And the console also does that. If I show my character 2 and I print it, you see here in the console it has a double quote. If you put a double quote inside of a single quote, it works. If you put a single quote inside of the double quote, it also works. But if you put a double quote inside the double quotes, then it will break it, because R will think that you want to stop your string, and then it won't know what to do with just one. And so you see, if I try to assign it, it actually just well, sorry, I misdone it. So you see, if I try to assign it, it says unexpected symbol, blah blah blah, so it has an error. To avoid that, if you really need to put a double quote into your character string, you can do a backslash. So the backslash will tell R that to avoid this special character, and then it will just put it as a normal character. Then the fourth and kind of more special data type are the factors. They're used and they're seen as the categorical variables that we would use when we do statistics or plots. And they're basically text, or they can be number that are seen as a category. So if I do my factor, it doesn't really make sense to make a factor of only one item, but for the sake of the example here, I would say, let's say sex female, and this would be a factor, so I have to say that it's as factor. So you see here on the right, my factor, it's a factor with one level. With all those data type, we can put a bunch of numerics together, or a bunch of characters together, or we can mix them up. And when we do that, we save that in a data type that we called the vector. And so let's create a variable called vec1, and let's create a vector. To create a vector, you need the function c. It's C for concatenate, which means to put things together, to one after the other. And so let's say that I want to make a vector of numeric values. I can do this like that. And here on the right, you see that it's a numeric of length 5. And at the far right, you have, under the column value, you have a sample of what this vector contains. And you actually see that my numeric, the variable to which I gave the value 10, is the same type as vec1. This is because in R, the single values are actually vectors of length 1. Vec2, let's make a vector of true and false. I can mix the different ways that I use true and false. I can use the short F and T, or the long false and true. I'd like to have values of the same length as the one above, not because I need it to be that way, but because I'll use it for example later on. So now you see that I have written a logical vector of 5 elements. Let's make a vector of strings, or of characters. A, B, B, my little story, Z. You can even put it a number. If it's between the double quotes, it will see it as characters. So Control Enter, you see vec3 is a character vector of 6 elements. To make vector of factors, I have to do as if I was writing a vector of character, but I will give all that to the function as factor. So let's make vectors that are categories, that are the sex. So you see here it's saved as a character because I didn't do the as factor yet, and now if I put as factor around it, you see now that it's a factor with 2 levels. There are the males and the female. If you put different data type together in one vector, it will transform it following some certain rules. So the first rule is that if you put only true and false together, they will be true and false. If you put true and false with numeric values, the true and false will become numeric values, and the true will be assigned a number, the number 1, and the false would be equal to to 0. If you put numeric or Boolean values with characters, everything will be transformed to characters. So here I'll give you an example of this instance. 1, true, and B, vector 5. You look on the right, it's a character of 3 elements, and if I print vector 5, you see that all items have double quotes around it, and it's because they were all transformed to character. Let's make the same example for a vector of 1 and true. I reassign it to vector 5, which overwrite what we had previously, and then you see that now vector 5 is equal to 1 and 1 because true was transformed to 1. So far now we have seen vectors. Vectors can be logical, numeric, characters, or factors. All of those can be given to another data type, another object that it's called list. The list can contain anything. It can contain a function, it can contain vectors, it can contain another list, and it can contain the data frames. We will see just after the list what data frames are. To make a list, you can use the function list with open and close the parentheses, and within that you can give it actually the variable that we created before. Those variables would be assigned as elements to the list. So let's say that I have vector 1, 2, 3, press enter, and let's say that I save it to the variable my list. You see here my list, it's a list of 3 elements, and if I click on the magnifying glass, it will open a little tab that will, and the name of the tab would be the name of your variable, and it shows that it's a list of 3 elements, 1, 2, 3. The first item is of type list, the second is of type double, which is synonymous with numeric, type logical, true, false, types character. The other thing that you can see is that they are not of equal length, those vectors. The third vector, the character vector, has 6 elements, while the other one have 5 elements. You can give only a vector of length 1 or just a number to a list, or you can even give another list to a list. Let's say I will give this list of vector 1, 2, 3 to the big list, and I will also give it a function, the function mean. And if I do enter, I overwrite the previous version of my list, and now if I go look at it, you see that it's a list of 6 elements, and the 5th one you can even open it because it's another list. Within that other list you have what our list contained before, because that's what we assigned to it. And so you see that the 6th element of our list is of type double, and it's just equal to 10, and it's a vector of length 1, which is shown here by the number in the square brackets. Our next data types are data frames. Data frames are a subtype of list. They are different in the tag or in the name they have, and functions sometimes they will read the tag that a variable have to decide which code they will run on them. And so by subtype I don't mean that they are the same thing, but they are very similar, and many functions, if they don't know how to read a data frame, they will just default to how they would read or work on a list. So basically data frames are lists with vectors of equal length. If I create here a data frame with vec1, vec2, and vec3, remember my vec3 is of length 6 and the other one are of length 5, it will tell me that it's not okay. Here the error in yellow, it says that it implies different number of rows. One has 5 and the other one has 6. So I would remove vec3 and let's create a data frame with 2 columns. Here it worked. You have the column will get the name of the variable by default, and here so you have vector 1 and you have vector 2. But I can, when I create a data frame, I can choose to name my column. If I wanted to name my column A and B, I would write it like that. And you see here now the columns are named A and B. I could use the long form of how I created my vectors, and that would be equivalent, and that would also create a data frame. You can see it below. Data frame in R are often saved with the as df, the variable df. And so if I do Control Enter, on the right you see here that my variable df is of type data frame length 2, that means 2 columns, and it has 5 observations. It has this little table symbol here that you can click, and it will open a tab, and RStudio will show you the content of that data frame. To do that, RStudio is actually just running the function view with a capital V. And so if you were to run the function view on your df in the console below and press enter, it would do the same thing. So you see here that df popped up. One thing to keep in mind is that often characters and factors are not interpreted in the same way by the functions in R, and that can cause some errors. And so if ever you have a problem and you don't know why your code is not working, one thing to check is whether your vectors are in the way that they should be. Are they in characters or are they in factors, depending on what you need. There is another data type called matrix. And so to make a matrix, you can use the function matrix. You can give it data, and you give it the number of rows and the number of columns it has. I have my vector 3, which is a vector that have 6 elements, and I would use that to create a matrix of 2 rows and 3 columns. If I do Control Enter, you see it down below. It prints my character vector, but this time in 2 dimensions in a matrix. I can save it to the variable my matrix, enter, and you see it on the right that it is saved as a matrix of 6 elements. And if I click on the little button that we used also for the data frame, we can see them as actually they are transformed to data frame to show it to you, because the columns are named v1, v2, v3, and I believe that my matrix by default does not have those names exactly. When you do call names, which is a function in R, on your matrix, it will give you the names of the columns, and it tells me it's null. But here on the top, you see v1, v2, v3. That was because RStudio by default assigned some values to those columns, because a data frame needs to have names on their columns, while matrix don't need that. Let's get to indexing now. So the first thing that we can index are the vectors. Vectors are in 1 dimension, so you will index them in only one way. It is with the square brackets like that. So let's say that we want the second value of our vector 2, of our vec2, which contains logical values between true or false. Say that I want the second one. I do vec2, open the square brackets, put the position 2, close the square brackets, and that will print, or that will return the false value, because you see that the second value here in 2 is F for false. Let's move all this indexing down in the console, because I don't want to save that work. This is just to show you what values are returned with different type of indexing. R starts its indexing at 1. Other computer languages can start at 0. So if I want the first value, I say 1 and my vector 3. Let's look at vector 3 just by typing it all together. It gives me, this returns me the 6th element. In R, you have a special character, which are the 2 points. And 2 points like this, 1, 2, 6, means that you want all the numbers between 1 and 6. So if I do enter and that, it creates a vector of 6 elements that are 6 numbers between 1 and 6. I can give that vector to my other vector that I want to subset, that I want to get values out of. And with that, I get exactly the same vector, because I wanted the first, the second, the third, and up to the 6th value. If I do that, but I actually put to 4, that will give me the first 4 values. If I do -1, that will give me all the values except the first one. Those are the most common ways that you will subset and that you will get values out of a vector. If I do 1 of 1, it returns 1 because 1 will be evaluated as a vector, and then we ask to get the first values out of that vector of one element, 1. If I do 0 of 1, it returns nothing. If I do of 2, it returns nothing because this vector contains only one value at position 1. So another way to subset or to get values out of a vector is to use vector of logical value. So let's say that I wanted only the second value out of my vec3. I would create a vector of all false except with the true at the second position, and then I'll do false, 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 and I think this vector has 6 elements, so this should be it. Yeah, so you see that my second value was b, and now I got a vector of length 1 with b. Remember, a vector of length 1 is equal to only one single value in R because there's no difference between one value and a vector of 1, 2, 3, 4, 5. It's just a vector of length 1. All vectors, whether they are factor, they are numeric, they are logical, they are characters, they can all be indexed or get values out of them in this way. If you have a list, you can, to subset lists, let's use my list. So to remind you what we have, it's a list of 6 elements. The first 3 elements are vec 1, 2, 3. Then we have a vector of length 1 that is equal to 20. Then we have a list of 3 elements that are the vec 1, 2, 3. Then we have the value 10. To subset or to get one element out of a list, you can use the position number in the double square brackets. So if I have my list, double square brackets, and I use position 1, I get my first vector. And you see that this is a vector that is returned. So if I had used only single square brackets, that will return a list of length 1. You see here, you can see that by having the double square brackets 1 and then a single square bracket 1 telling you that it starts at position 1. So we want a list with names. We need to give names to our list so that we can filter and subset this list using the name. First name, let's give the name A to vec1. Then maybe we can give the name vec2 to a variable vec2. We could also write the name without the quotes. And so I can say name without quotes equal, in this case of list definition with names, it would work. Then let's go with my number equal, and maybe let's stop there and not give names to the rest. Let's go back down. Let's print the whole list, writing the name. So here you see that after the $, you see the A. There is, and then you see what the vector is equal to. And then you see $vec2, that means that it's the name of this list as this position is vec2. And then you see that I also wrote the name with names without quotes, and it's there. And then my name, and then for the other ones, you only see the position of that vector or of that element in the list. And this is because we did not give it a name. If I do names on the variable my list, we see that it has the name A, vec2, names without quote, my number, but it doesn't have names for the other ones. To filter that list, I can write its name and then use the $. And you see that RStudio will give you suggestions, and basically it will suggest to you all the names. And so names without quote, enter, and I get the vector at this, the vector that is assigned to this element of the list. Subsetting by position with the double square brackets still works. So if I do my list 3, I get the exact same thing. So it's just a handy way to access your data. Now let's move on to data frames. And data frames, they can be subsetted just like lists. If we had defined the variable df before, so we had the column A and the column B, and so I can use df $A, and I get my vector at the A position. I can say df double square brackets 1, and I get the first column. Double square brackets 2, I get the second column. If I get a vector like that, when I use the double square brackets, what is returned is a vector. So you see it is just a vector of numbers. This is the column. So then at this point, all the ways that I have learned on how I can subset a vector works. So I can then put square brackets after that and ask for 2, and I get asked for the element at the second position, and I get it. If I get the element at the fourth position, I get 23, etc. I can also get several values. So, you know, I want the fourth and the fifth values, and I get those. You could also use the true and false. And the last thing is to use single square brackets, but then to use the same syntax as we would use on a matrix. Let's say that we were thinking of a data frame as just a two-dimensional array or a two-dimensional matrix of values. We could ask for the values at the first row, second column, and then we get true because this is what we have here in this data frame. If I want maybe all the values at the first row, I can write 1, comma, and then put nothing, and then I'll get all the values on that row. If I want all the values on the first row, on the third row, and the fifth row, I will give it a vector of positions, and I will get those positions. We can do the same with the column, and so I can ask only all the values for the second column, and this is exactly equivalent to calling it like this or calling it like that. Then the last data type that we had was matrix, and our matrix, in this case, we called it my matrix, like that. Here you even see the way that you can subset it or filter it. It's the square brackets, and then it tells you here that this, if you write square brackets 1, comma, square bracket, you will have the first row. And just to prove it or illustrate it, I will write the 2 like that, and we got B, my little story, and 20. So those are the way to index variables or to index data type. Now let's move on to functions. How do you define a function, and how do you use a function, and how do you know how to use a function, what to give to a function? So first, let's define a very simple function. So we will create a function that we will call my sum, or let's say new sum, just to show you that we can do other thing than my. So new sum function, open and close the parentheses, and then we will say value 1 and value 2. These are the arguments to the function. They are the variable that we will use inside the function. So the user of our function will give something at the first position and something at the second position. When they do, value in our code will be equivalent to what they put in those positions, and the code would be evaluated using those values. So let's say that we do a new sum. So we just want to have value 1 added to value 2, and we will return the results to the user. And so basically this says create this function and assign it to the variable new sum. Control enter, we created it. Now let's use it. Let's write new sum, and then the first value I will put 10, and the second value I will put 20. I do enter, and then I got the results. It's 30. Let's say that our value were not equivalent. Let's say that we were to do a division. So let's call new division, enter. And then if we do new division, Then we divide the first value 10 by the second value. In this case, let's go with 20. We will get 0.5. If I wanted to use this function, but I wanted 10 to be the divider, well, I just write value 2, the name of the argument that was chosen by the function developer, and then I can do value 1 after that equal to 20. And so you will see the result to that are not the same. The result to that is 2, because now value 2 was equal to 10, value 1 was equal to 20. But when I omit this equal, R will take the order of the arguments and will assign it to the value in turn. And all arguments in a function have to be separated by a comma. When developer develop a package, he or she has to document this function. And so let's go for an example of documentation. So let's look at the mean. And then on the right here, you can see that the mean will take a x, and then it tells us that the x has to be an R object. It says that there are methods, so there are ways to do the mean on numeric or logical vectors. And it also says that there is a way to do a mean on date, date time, and time interval objects. So those are kind of special data types that you don't need to know right away. And complex vectors are also allowed, but this is also something that you will not use daily and use often. So, but the first important part, the way that you usually use a mean is with numeric values. And so it tells you that the mean will take a numeric vector. That means that you can't put a list in the position of the x here, or you can't put a data frame, otherwise it would break. Or if you put a character vector, it would break. And remember that when we have characters mixed up in a vector with the numeric, it transforms everything into character. So maybe you wrote a character and you wanted to have null values, and you put them into a double quotation. If you look in the list of arguments just below, the developer of this function tells us that the x should be an R object. The methods, that means the different types of code that can be given to this function, are either numeric or logical vectors. That means that if you give it a data frame or if you give it a list, you will get an error. This function can take also other arguments. As you can see in the usage, you can take trim or NA remove. Those are two more arguments. Trim can be a fraction, they say. In this case, the person developing a package chooses what is written in this text. So in this case, the person did not tell us exactly what was the data type that trim could take. They tell us that it can take a value between 0 and 0.5. And so we can assume that is basically a numeric vector of length 1. Trim has a default value. And you can see that trim has a default value because in the usage section, when you see the word trim, it says trim equal to 0. So that means that trim would get the value 0 if you don't give it a value. The same is true for NA point remove, which is the third argument of the function mean. It is set equal to false, and so if you don't give it anything, the option NA point remove or the argument NA point remove is equal to false. You can give it a logical value that will indicate that you want the NAs to be ignored. You will have references and the example as I shown before. So this is how you can interpret and how you can read the R documentation. Keep in mind that functions of packages are written by anybody that chooses to write a package. And so although they have to be documented, the level or the how you decide to document it is up to the developer. That might be a source of confusion for sometimes, or that might explain sometimes that you don't quite understand the language. And so you have to keep in mind that it might be different people that write different functions. And so you will have to interpret what they say in this context. We have defined functions, we have used functions, and we have learned how to understand or how to guess what is a function or what contains a function. Another way that can help you understand a function but this might be when at a time where you get a bit more advanced, a bit more used to R. But it can also be a great source of learning, because basically what I would show you is that if you just write the name of a function, the name of the variable containing the function, without the parentheses, you will get to the code of that function. And so here in that case, I wrote new division on my source script, and then I pressed Ctrl Enter, got my new division, it was interpreted in the console, and you see all the code that I have written to define this function. By doing Ctrl-Shift-1 or Ctrl-Shift-2, you can move between the source script or the console, and this is why you see now the window changing. Last thing you should know to be ready to go on your own and code and learn anything you want in R is a little crash course on packages. Packages, as the name says, it's a bundle, it's a library, so it's a collection of functions, or even sometimes even data. Packages can be developed by anybody. Anybody that starts to code some function and they put them together can package them. And then if they are formatted in the proper way, they can be submitted, packages can be submitted to CRAN. CRAN is the kind of the website or the server that hosts all the packages and makes it possible for any user to install the packages within R. One of the most popular package in R is the package ggplot2, and this package is really helpful to make graphs in R. Let's say that a friend told me about ggplot, and so I want to use it. One thing I can do is that I will go in my console. Well, actually, yeah. It's better to write that in the console than in the source file, because you won't rerun it every time. Packages are installed once on your R, and they only need to be reinstalled when you install update R, when you install a new version of R. So let me go to my console, and then so I would install, and you see I start to write the word installed. RStudio suggests to me to use the function install point packages. I will do that, and then install point packages will take the name of the package in double quotes, so as a character string, and I know that the name of this package is ggplot2. Press enter, and then it will automatically get installed on my computer. Once this is done, the only thing I have to do is that in my script, in my code, every time that I launch RStudio, I have to call the function library, and then I have to give it the name of the package that I would want to use. And now I will have all the functions from ggplot2 available for me. The main function is ggplot, and then that will take a data frame, and it will take another function as an argument, which are as for aesthetics. My data frames, I can give it just the name of the variables, A and B, and then I can do plus geom point plus geom point, Control Enter, and you will see that I get a nice graphic, a nice plot. Remember, this data frame contained trues and false, and it had values between 0 and 23 point something. So this is how to install and use a package. If I know about my package and I know it contains some function, but I'm not quite sure about their name, one useful trick in RStudio is to type the name of your package and then put the 2 semicolon tab to start to search. And maybe I know ggplot has some geoms, and that dictates which type of plot I want in ggplot. And then I can look through it. I have a list of all the functions that contains the abbreviation geo, and then I can choose, and that can remind me which function I'm looking for. I will make another video on a very in-depth tutorial on ggplot. The point here was not to show you ggplot, so that's why I went quickly through it. It was just to show how to use a package. So you can write library, and then you can call all the functions within a package. So that's it for today. That's it for this video. I showed you how to use R and what R was. It's a language, and it's also an interpreter. I showed you that working in the console is doable, but it's not the easiest way to learn. The easiest way is to use the integrated development environment, RStudio. I showed you the basic data types. Those were numeric, character, logical, and factors. I showed you that all those can be put together into vectors, and vectors can be holded together and can be put together into a list. Data frames are special types of lists, and matrix are special types of vectors with more dimensions. I showed you how to index and how to get values out of those data types. I showed you how to use and write function. I also explained how to install and work with packages. I have not showed you the specific syntax for the different operators, but this is something that is well documented in a nice cheat sheet, and I will give you the link down below in the description. On that, I hope you like this tutorial.